Hi there, welcome back for an explanation of the homework for Unit 1, Lesson 9. What we see with this lesson is that we're going to do a little bit more of our practice with rotating lines of parallel lines and other lines, just as we see the intersection. For the first problem, number 1, what we're going to do is draw parallel lines A, B, and C, D. And you might be saying, well, how am I going to draw parallel lines? Well, my method for this is I take a ruler, and I know that on both sides of that ruler, we should have the same distance on both sides. So I just take my ruler and I like to draw two lines just like this. Those lines, parallel lines A, B, and C, D. So this line will be A, B, and this line will be C, D. And then we're going to pick any point and rotate AB 90 degrees clockwise around center E. So we just pick any center E around here. We do that rotation of 90 degrees clockwise, and when we see that rotation of 90 degrees, we should see that we have a relationship between these lines that is constant. If you remember, the lesson today was about recognizing the consequences of rotating and reflecting and translating parallel lines. We know that that rotation will not change the reflection of the line, or the relationship between the lines, that those lines will still stay parallel. Just give me your best effort to draw that 90-degree angle. I know you may not have a protractor, but you could use a corner of a piece of paper or something else. And then I think I already gave you the answer for part D. What do you notice? Something about the nature of the lines were parallel to begin with, so what happens after that? Problem 2, we use the diagram to find the measure of each angle. Now you might be saying, well, Mr. Quilter, how am I going to be able to find those angles? Well, we noticed that they gave us one of them right here. And with having that one angle, we can find all of the rest of them. If you continue on from here all the way around to the other line, we know that that's going into half of a circle. And we also know that this is a straight line. So that would be a straight angle. I'll remind you that straight angles equal 180 degrees. So with that in mind, what that would tell us is that since angle DBC is 50 degrees, the remainder of the way around here has to add up to 180 degrees, and we're saying, what's the measure of angle ABC? So we have a question mark right there. Well, if I take that logic of straight angles is 180 degrees, then 50 plus what is going to equal 180 degrees? If we subtract the 50 from 180, we get 130 degrees, and we should see that the measure of angle ABC is equal to 130 degrees. We can apply that same logic as we continue to move around this figure to find out the measure of angle EBD and angle ABE. We can also use one other thing that we reviewed today, and that's the principle of vertical angles. We know that under a rotation of 180 degrees around a center point where two lines intersect, we get vertical angles. We also learned that vertical angles are always congruent because of that rotation of 180 degrees around the center. Keep that in mind as we go through these two pieces. Problem number 3, we're going to plot points P and Q on a line, or they are on a line, and we're going to find a point R so that it is 180 degrees, so that a rotation of 180 degrees rotated around center R. So you get to choose wherever you're going to put point R. And then you're going to go ahead and perform that 180 degree rotation. And it says, is there more than one point R that works for part A? Again, so when we look at the second part, we're going to say find a point R so that a 180 degree rotation with centers R sends P to Q and Q to P. So that might be a little bit confusing. Just go ahead and pick a point right here. Will that work to get these two around here? There's a little thing that we talked about a couple lessons ago that I want to give you a hint for. And I want you to think about midpoint is what they're really looking for, midpoint. So I'm going to tell you under midpoint, that's not going to work right there. The goal of this is I want to get the center of rotation to be able to map point P to point Q. So when I make that rotation, P becomes Q and Q becomes P. So where would that center point have to go on here? Number 4 in the picture, triangle ABC, A prime, B prime, C prime is an image of triangle ABC after a rotation. The center of rotation is D right here. What is the length of side B prime, C prime? Well, in order to find this one, we're not going to use a ruler or anything. We're going to look over our other triangle because we know under rigid transformation that our rules follow that all the corresponding side lengths are the exact same length and all the corresponding angles have the same angle measure. We should be able to use all of the information that's given here to be able to determine the length of this segment here. We should be able to determine the measure of angle B. So we're going to be asking, what is this measurement here? What is this measurement here for angle B? And it says, what is the measure of angle C? We should be able to use all the information that's given here by comparing this triangle to this triangle and remembering that rigid transformation preserves the lengths of segments and the measure of each angle. Final question is question number 5. It says the point -4, 1 is rotated 180 degrees clockwise using center 0, 0. What are the coordinates of the image? For this one, I want you to go ahead and find a piece of graph paper or go on to the Graph Masters document that I shared with on Google Classroom and go ahead and make a coordinate plane graphing the ordered pair -4, 1 and then perform a rotation of 180 degrees counterclockwise. For this problem number 5, I'm going to make this one extra credit. I'm not going to talk a whole lot about this one, but I really want you to see what the coordinates of the image are, and I want you to see what happens to a single point on a coordinate plane when it's rotated around the center 0, 0. What happens to the ordered pairs? Thank you very much for coming back for homework. If you have any questions, be sure to send me an email. And remember that you are never allowed to give up. Have a great day.